All right. How's it going, everybody? Welcome back to the Incus Project. Uh, I guess we just keep working on what we've been working on. We have to figure out some more things about the motors and that whole circuit in the lightsaber today, so that's what we'll be working on, and then hopefully moving on to the speaker as well. That circuit, I really don't know what we're gonna do yet. I'm gonna have to look around some and try and figure some things out. So, anyways, if you have any questions or suggestions, as usual, or just something you want to chat about, let me know. Otherwise, I'm gonna keep on working. Let's get to work. All right, so last time we went through and did. This is the power supply. I was confused about this for a second. Hold on. Motor. This one. This is what we worked on. And we ended up doing a whole bunch of things to make this work. And I think we might need to keep doing this. We need to do some sort of thing here to turn this chip off when it's not being used. Probably on both sides, honestly. All right, let me look at this chip again. L293E. I remember there being something about it consuming a lot of power. So my big fear, right, is with using lithium ions. Like there's a point to where they stop discharging, which is around 3 volts, I believe. So 6 volts overall, and that's still enough to supply our voltage regulator. So anything that draws a ton of power is just going to drain the battery over time, even if the device is off. So I need to be able to shut the circuits down. So L293E. So let me see what our power draw is looking like here. It's a lot. It's in like the milliamps range. Yeah, this is something that's got to be turned off. I think I was originally going to wait till the end to do it because I was going to have to take up some more I/O, but I don't see a world where this works otherwise. So we have one here, we have a couple here that we can use. We're going to need 2 of them. All right, that sucks, but are P-type MOSFETs active high or low? I cannot remember. P-channel MOSFET truth table. Maybe this will tell me. All right. Hold on. P channel. Q1 turns off when it's high. So it turns on when it goes low. So we need to hold them high. Oh, that's kind of disappointing. I guess that makes sense though. So holding them low turns them on. Okay, so I'm kind of confused about this then. Maybe my understanding of this stuff is, unfortunately, it's really embarrassing, but my understanding of transistors, I guess, in general is not as good as it should be. Especially for doing this kind of stuff. So let's see, N channel in enhancement mode versus depletion mode. Oh, they're different types. Yeah, I'm gonna have to look over this super carefully, geez. All right, so what can I do here then? I guess I have to hold it high, even when the chip is off. So what we need is one more of these, two more of these. Okay, so Q18 and Q19. Give it a sec to load. All right, and then wiring it up. So I guess the same thing, power to the device. I don't see much of a point of a pull down here. What is this again? This is the ERJ. 10 kilo ohm, that should be fine. All right, so let's pull up my bill of materials here. Oh, I don't know that these ever got added. All of the bomb. 17, 18, 19. Okay. And then R25 is this resistor. All right, so let's place a part. Here we go. All right, so we're going to need pull-ups on the input lines. And then we're also going to need them on, oh, come on. Will we need them on anything else, actually? I think we'll be okay. Yeah, all right, I think that'll be fine. Let's just go ahead and turn these Comments off. And then rotate it. All right. And then to wire it up, we need power coming in, going to that, and then from there to there, and same thing here. And then this just gets wired out here. Whoops. All right, then we'll label this net. I guess aux power? Aux supply? All right, I'm going to add this to the spreadsheet. Whoops. It goes to pin 16 of what? Use PFET. Okay. Let me just pull this over here so you all can see what I'm doing. All right, then we need to put this one on somewhere. I guess this I2C is going away. There's still probably a lot that can be done to this circuit. I may be adding like jumpers and things so that I can populate stuff as I want to. All right. R26 and R27 need to go in the BOM. Yep. Keep this format. And then we have to go back to our teensy. Oops. The ever growing whatever this is. All right, 16 is aux supply. And 35 is aux power. Okay. Do I have a plan for pin 34? Power button in. Connector 0 ohm jumper. Because that's not connected. I missed something there. All right, I need to double check some things. So apparently there's some stuff I missed when I was supposed to be wiring all those up. Let's go to our power supply. Did I have this somewhere? PWB in. No, it'd be on the buttons. PWB in. Yes, I just don't have the 0 ohm. If I don't have a 0 ohm in the bomb, I probably need to do that now. Because I will need that at some point. Looks like I don't actually. Jeez. Okay. That's gonna be our next thing is to. So, all right. So I think to sum up where we're at. I think the motor thing is okay except for the connectors. Oh no, it's not okay because we still gotta connect these wires. All right, hold on. I am all over the place right now. Let's stay focused. All right, so we need to change these. Whoops. Five volts, aux 1. 5 volts, aux 2. And we need to do that here. Volts, aux 1. And then down here, 5 volt aux 2. Okay. All right, so that makes sense. Man, I can't wait to see all the amazing software libraries I'm going to have to write to do all this, to abstract all this hardware. There's going to be so many functions for just turning circuits on and off. Okay, all right, so that's done. Motor looks good for now, except for the part where nothing is connected coming out the other end. Obviously, we need to go to some sort of connector for that. So that shouldn't be too bad. And I can get to that in a second, but what I want to do right now is add a 0 ohm jumper to the bomb. Oops. Because we're going to need to be able to connect and disconnect things later if we figure out how they work or not. And then I want to go through and double check all these connections so far because it seems like we're missing a few things that we should have. So I just want to run through it all. See if there's anything I forgot to add, like that power button in. So first things first, 0 ohm jumper. So I guess digit key. There's going to be 1,000,001 of these. Every company in the world is going to have one. All right, in stock, active, cut tape, option, 0 ohms, excuse me, 0805. 25 results. Okay, not as bad as I thought it was going to be. Find a cheap one and then see if it exists here. This looks good. Please, please, please. Hey, there. All right, we got one. I'm going to go ahead and place this. And it's going to be down here. And then let me add this to the bill of materials. Which resistor was that? R28. And we're going to add probably a lot more by the time this is done. Assuming we do this right. So effectively what we could do with these jumpers is create points in the circuit where we can connect or disconnect lines at will. Just a way to find out it works better with or without something. So you can, and we don't necessarily have to use a 0 ohm on these points. We can use any value. So we could put like a pull up and pull down on something using the 0 ohms and then populate it with whatever the heck we want later. We just got to be careful that we get it right and that we don't actually put a 0 ohm tying something to ground or to power, because otherwise we'll have a short. All right. So that looks good. Let's run the wire. All right, and then put a label on that. And this is pin 34, and we have definitely decided that, just to double check, power button in. We would have had to connect the main one to the, okay, hold on. PWB in. All right, let's change this to not have that. Okay. Where does the power come in at? Power management on off. Should be down here. This one right here. That's not connected through a jumper. How did I miss that? All right, well, gives us another one already. $29. All right, we're gonna delete this, delete this. Why is it underlined like that? That's weird. So, ideal world, only one of these will have to be connected. Okay. So that's done. So now I need to go through basically everything here and just make sure it's all connected up the way it's supposed to be. So going around ground. All right, 0 is accelerometer, 1 CS, 2 is MISO 1, 3 is power button in dB. Did I change something? Did I have the power button coming in at multiple locations? I might have done something like that. I think 34 doesn't need to be that. Because we already have that connected elsewhere. Yep. It's already connected here through R12. What is R12? 1 kilo ohm. Okay, so debounce. Yeah, then we definitely don't need this here. All right, so that was a mistake. But that's okay. We still have it connected down here like we wanted, so that's not the end of the world. Take out R28. And then let me edit this so that's not a thing anymore. That leaves line 34 open for other stuff. Okay. Red PWM, green PWM, blue PWM, screen A0, screen reset, screen backlight red, screen backlight green, screen CS, Mosey, Miso 3v3, tactical switch 1, tactile switch 2, Mosey 1, SCK 1, tac switch 3, tac switch 4. All right, next two, NP and SDB. And it's in relation to this chip that I have listed here. What is that? All right, that's the speaker amplifier, so those aren't connected yet. We'll get there. All right, so moving down. 32 is blade power, and then 33 is hilt power. Then nothing, and then aux power. Okay, accelerometer 0 CS. Motor enable, motor 1, motor 2. Aux enable, aux 1, ground, yep. SCK, aux 2, screen backlight blue, auxiliary supply. Then I2C SDA 1, that's not going to be a thing anymore since we don't have the other one available. So that's a free one. I2C SDA, SCL. Blade NeoPixel, hilt NeoPixel. Okay. 22 and 23. Charge status in, charge status out. Okay, so we messed up our charge status lines as well. So through a 5 volt to 3.3 volt divider. I wonder if that makes sense or if I should just do like a level shifter. Nah, divider's probably fine in this scenario. Okay. All right, so this charge status, if we go to the supply document, pin 5 here, the status line, this isn't even connected and it needs to be. Don't know how that was missed. Basically gives the status of whether or not it's charged, if it's charging currently and whatnot. So if that's the case, yeah, we definitely need to connect that up. And it looks like it's 5 volts out. Look up this part real quick, just to double check. Whew, I'm tired. Three-state indication of charge in progress, charge complete, or temperature fault, or sleep mode. Yep, that's a 5 volt pin. Okay. So if I've not done this yet. What are values recommended for I guess it's just half on the one side. All right, I'm just gonna use a quick voltage calculator here. Input voltage 5, if we do 10K, well, I need to do it the other way. 5K, 10K, what we get is 3.33. Yeah, that's acceptable. All right, so I'm just gonna do a 5K, 10K. Since we already have 10K and I just need to add a 5 to do that. All right, so I need to find a 5K resistor. Shouldn't be that hard, theoretically. Not that many, apparently. 5.1 would be a little better. Get us closer to the ideal 3.3 value. Let's try a 5.1. There wasn't a lot of options for a 5K. Oh yeah, that's a 43 remaining G's. Okay. Here's the Panasonic electronic components one. Excuse me. All right. Hopefully it has a model. It doesn't. That's a new one. All right. Let's find another one, I guess. Any number of the 10-cent options available. That works. Drop that right there. And then we need to go back. Oh, here. I'll have to add this to the bomb real quick. So R28 is what this one's going to be. All right. And then this one. All right, let's turn the values off. Or the comments. I like how the symbols are like way different too. Yeah, this might get a little weird actually. All right, R30 for that 10K. All right. Okay, so now we have charge status in, charge status out. What's charge status out need to be? I guess they're a 1K to this position here. All right, so this... this in. All right, and then, oops, our teensy document. So 22 is charge status in. All right, and then this one is charge status out. All right, and then this needs to be connected through a 1K to the in, I believe. I need to double check what it does here to indicate the status. All right, so here's what I'm looking at. Reports the status of the charger on a 3-state status pin. The following table summarize the operation of the status pin. So the status pin can be used to drive a single LED, or, okay, yeah, so the out is connected through a resistor there. Always match the signal. Okay, so, and if it's in high Z, it's in temperature fault or sleep mode. Sleep, I'm assuming, being not charging. Like, just off. If the VCC falls below the voltage at the battery input, this feature prevents draining the battery pack during the absence of VCC. Okay. Cool. I think... So that's how that works. So we need to get the 1K resistor that we use. This one. And place this part. Yep. All right, and so that adds R31. So many components, geez. And then we'll turn off this symbol here. All right, and all that stuff's labeled, so it should be fine. And then that should be everything that needs to be connected right now, which is a lot. Okay. So now I need to find a connector for the motors. Motors, whatever. I need an 8-pin. And probably a new sheet to put it on, because it's not going to fit here. Well, maybe. If I move all this over, I might be able to drop it somewhere. Oh, dang it. There we go. I might be able to put it over here. Okay, I need some sort of connector for it. What were we using before? Does that have a dual row? We need like 8 pins. But I don't want to use anything too big. What were you? It was the NeoPixels was using a connector, right? Yeah. Oh, but we might have changed the size on those because of power reasons. What was something else we were using a connector for? Buttons? Yeah, this one I believe was pretty small. Alright, let's see here. Digikey, connector. What is this particular thing that I had? The 503, 763, 0391, right? 0691. This thing. Did they make an 8-pin version of this? The other one was 0391, this one's 0691. I bet if we change this to an 8. Ah, that is not apparently an option. Maybe 6 pins is the max. Alright, we might have to find something new then. So let's find it. In stock, active, apply all. I really don't want to have to make something, so hopefully I can find something. Number of positions, 8. There's a lot of wonderful stuff here. Interesting. It needs to be something with a positive lock or something, because this is going to be next to the motor, which is going to be shaking. So it can't just be friction. I don't want friction lock. Latch lock or locking ramp. Something like that, maybe. What's the pitch that we can get? Oh yeah, those are excessive. Jeez. Maybe a different pitch then. How about 2 millimeter pitch? Something this tiny. Nope. I might have to come up with a better option than those locking mechanisms. Let's see. Don't want anything horrendously expensive either. If anybody knows of any that they want to shout out, I'll definitely listen. You know what? We can probably mark right angle or something up here. Let's do that. I want a through hole right angle. I don't care if it's a board edge. You know, as much as I hate to do a friction lock, like I'm seriously considering it just because it'd probably offer the most flexibility and use the smallest space. And it would be cheap and likely already have a model put together. Yeah, I think I might just do that for this. Probably use a Samtech part just because it's likely to have a model. Something like this. Let's see. Alright. Ah, nope. Let's find something else then. There's other Samtech parts here that aren't bad. Actually a little bit lower profile, so it might work better. Nope. Alright, keep looking. Yeah, alternatively, for space-saving reasons, we may just want to go with test points. And, like, just big vias really to solder to. I wonder if this thing has test points defined in here at all. It does. Well, it uses a certain test point, but we could definitely make use of that. What's 0.07 inches in millimeters? 1.7780 millimeters. What's the outer diameter? 0.22 inches. 5.58. That seems enormous. I need to see the footprint. Footprint is not present. You know what? I'm gonna place one of these and see it, because I want to know. Alright, let's validate this. No errors. Sweet. Update PCB document. This is gonna be a lot of stuff added. Not really, but a bunch of lines created. Come on. It's loading slow, which probably means my stream quality is dropping. Alright, validate changes. Everything except all the creations, right? Queue changes. Add class member. Oh, it's unnamed. Dang it. So I'm probably not going to see it here anyway. Alright, hold on. The slowest loading program in the world. Alright, so let's go power supply. Where do we need to go? Motor? Here. We need to name this. Okay. Surprised I didn't catch that. Yes. Add TB1 to motor, validate changes, execute changes. Didn't work. Cool. There actually may not be a footprint for it, just a symbol in the schematic. Which basically makes this impossible, so. Move everything out of the way. All right. So many parts. Such a wonderful little web. All right, so I need to find an actual test point that I can use, evidently. Motor, because this does not have anything associated with it. No footprint that I can use. This one does. Test point miniature. I really don't want I don't want a miniature. What about this one? Sure. 2.54 millimeters, so 0.1 inches. So that's sizable. Definitely solder whatever you need to into it, if you had to. Okay, that works for me. And they're small enough to fit easily on the schematic, so. So I need to do at least 4 grounds, and then 1Y, 2Y, 3Y, and 4Y outs. Two, 3, 4, 5, 6, 7, 8. Turn that off. I'm not going to add these to the bomb because I don't intend to populate them. There's those little test point connectors you can buy, and I don't really care for them. I mean, they're useful, but I don't need it here. Whoops. 2, 3, come on. 3. Oops. These are hard to work with, actually. All right. And ground. All right, and then underneath each one, we need our actual test point. Come on. All right. And then for each of these, we need to have a wire out. We'll probably have to go back through our whole schematic too and add this everywhere. May want to do this on all the connectors as well, because it may make more sense just to do wires to a lot of things rather than big bulky connectors. I didn't use that label anywhere else, did I? 1Y? No, I don't think I did. Okay. All right, then we can do the same thing up here. All right, let's validate all that. Good, and then update the document. All right, everything that gets added this time. Which means we have a bunch more stuff now to go move around, as usual. Whoops. Didn't want that. Come on. Get a test point. Yeah, these are... they're hard to even work with here. I just want to move it. I just want to move it. There we go. Well, let me put it down here. It will, okay. Oh, there's the limit. Oh, not Q4. All right. That looks good. Let's look at the 3D model here. Oh, it's got them all in place too, look. Interesting. Okay. So the VIA is not actually that big. But that's okay. It's still usable, but interesting. All right. So that's that done with the motor. So now the speaker, which I'm going to be honest, I have no idea what we're going to do. I had some wires for the speaker, but it seems like in a speaker controlled circuit of some sort, you really need a wave. You can't just do a digital thing. So we really need a DAC, a fast one, which means we have to run it fast. So we probably need SPI to run it. So yeah. And I know I found a circuit the other day when I was looking at stuff. So let's look at speaker breakout board, see if I can find something. Interesting. Plug and play audio amplifier from Adafruit. Question is, does this have any logic in it? $3885. I'm not going to use this, but I want to see like their circuit. Alligator clip. Interesting. Oh. Just. Ah, found a schematic. This is going to be really hard to see. Lower frequency noise is present. Ground, VDD. Ground. Interesting. Very interesting. Oops. All right, hold on. Oh, they have a volume switch. That's what that is. It's like some sort of potentiometer. That was what I was worried about. I suppose we could do something like that. I would rather it be controlled by the micro. Maybe we could do some sort of SPI controlled potentiometer thing and then do something like this. Ugh. Ugh. There's an answer here. I can feel it, but whoops. We have to look through this some. Yeah, I'd much rather do volume adjusted via the micro. So, all right, I'm gonna need both these things pulled up at once. Okay, so what are we looking at here? Yeah, I think we're looking at an SPI controlled potentiometer thing. Huh, weird that when I zoom in, it's adjusting both pages at once. So signal comes in, goes through the potentiometer. And then we control the speaker on the other side, which we might be able to use our speaker that we were already working with for this. VDD is pretty tolerant. It can have up to 5.5 volts, which we would probably do. Well, we should probably do whatever the micro is going to be at, so 3.3. Actually, I don't know what we should do. I need to look at how much power that thing can use. Probably the 5-volt line, actually. Okay. I need to know what part this is then. This is going to zoom way in on this other screen because I'm looking at two different things at once. Here. Come on. There we go. Is that a P? PAM 8302A? Okay. There's other little boards you can buy that use it. I need a data sheet for the chip, though. Not really any easy to use packages, unfortunately. Like things that are easy to solder. Seems pretty straightforward, though. So we could still just use 2 lines to control it like we were originally planning. Okay. I can get behind that. What's input high and input low, 1.2, 0.4. Okay, cool. So it has its own like internal regulator, I guess. Oscillator, driver, thermal protection, I guess. Ugh. 8 milliamps under no load. I wonder under load like what the max usage is. I like this chip a lot. I just don't, it's tiny, it's hard to use, but we might be able to look for something very similar to it. 2.5 watt filterless Class D mono audio amplifier. I know we picked something originally before I had a moment where I was like, I'm not sure what this circuit does. So this amplifier, I wonder if this does like a similar thing. Since I see it being used here, that makes me feel a little better. So we might be able to do something. Yeah, 1.2 watt. Maybe an easier to solder package here. And then NP, bias, SDB. Yeah, this is a little less powerful of one. Kind of. Seems pretty similar though. So this might be doable. I need to look at the Adafruit one again and see how they plan to control it. That plays a different wave file. So there's got to be something. I just need to know if it's using like a PWM or a DAC of any kind to make this work. Let's look at the overview again. Our favorite little 1 watt 8 ohm speaker. Small screwdriver. Doesn't say anything about that. We decouple the signal so it can be AC or DC coupled. Usage doesn't explain. View on GitHub. Oh, well, that's, useless. Play tone. Oh, wow, they have a lot going on here. Just gonna Google and see what I can come up with. Okay. When I Google that, it just comes up to the same thing saying, hey, just use this play tone thing and you'll be good. But I need to know what it's actually using. I'm guessing it's some sort of PWM. Weird. Okay. Well, I guess I can figure out this later. I need to... Let's see here. I need to see what pin it is connected on. NP is on pin 30. All right, let's go TNC 4.1. All right, here we go. Pin 30, if that is correct. Yeah. Is just a digital one. I need it to be on a PWM just in case, and preferably also it's like a PWM and DAC pin, if that were possible. What is available here? Pin 17 is available. But that's not a PWM. That's just, but it is an analog. Although I think those are typically analog in. Hold on. Oh, I've got so many windows open now. Let's move everything back around. All right. Okay. That clears everything up pretty good. And then see 3.1 DAC. Okay, it looks like there is no DAC device like on the TNC, so we need to use an external one if we're going to do that, but I don't want to do that. So we need to go with the PWM, which I guess means I'm going to get rid of... I think I'm going to switch and leave this other I2C available. I put aux supply on one. I think I'm going to switch and leave that available. Okay. So 18, or actually 16 and 17 is what we want to look at. 16 is SCL. And I don't think we're going to use these. I just want them available just in case. I want to use them last if we decide to use them. Okay. So aux supply is down on pin 19 now, so we need to change that here. And then we delete this one. And then the SDA becomes the line for power, or the signal. So where is it? Here, NP. And then we can remove that from here. Unmerge. And delete that. Okay. And that leaves us another line open up there for something. Cool. And then that goes there. All right. So then it looks like we are going to use this part, and I'm probably going to do the test point things for the speaker again, just because having so many connectors, and I might actually pull out some of the other connectors that were in this device, because having so many is going to be a nightmare. Okay. So I guess now we need to put this part on the schematic. First things first, let's go ahead and update the board with everything. sure everything's not overlapping. What is going on here? What on earth? This is related to that resistor I added for the jumper, but what on earth is that? All right, we'll come back to that. The rest of it looks good. Okay. So now, let's go back to our speaker and see if we're any chance at all that this part exists. Yep, no model. Okay. Well, looks like we're making one. And then we also need to do the the Spi Controlled Potentiometer. Alright, I gotta see if I can find someone to key for it, but we'll have to make this part too. I'm gonna go ahead and create the footprint for this real quick, and then probably call it there, and then we just keep working on this more next time. Alright. New symbol. I need to go find this part. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Let's see, that'll work. All right. And then we need to go down the row. So this one is SDB. And it is 1. Oops. 2. And bias. This is NP. And 3. In N. 4. Out P. 5. VDD. 6. 7. I'm getting really tired, man. Out N. And 8. All right, that's good. Then we need to add a footprint. Let me find it. Hang on. Here it is. Did it not give me a footprint? So here's the drawing of the part. But it doesn't look like that they gave a footprint. So I guess we gotta randomly make one. This is an HTSOP J8. Okay, it's a package that ROM uses for a lot of things, so here's a generic data sheet on it. Hey, which has a footprint. Does this have a ground pad? No, it doesn't. Does it? Hold on. Oh, it does have one underneath. Oops. Well, that was a mistake. Well, I did remember picking this part for a good reason, so... Oh, it's for thermal stuff. Alright, fine. I guess it can get hot. To ground. Okay. We're going to have no choice there probably, because there's probably going to be like a lot of different things use that or something. Come on. There we go. All right. 1.27, half millimeter pitch. This is going to be kind of hard to use, but... Rectangular. This is in millimeters. Okay. Let's change this to metric. Oh. All right. Three 5. 0.75. Okay. Hole size 0. Right? No. Top layer. That's what we want. Okay. That's probably got everything we need. Probably good for the paste and all that. So now the positioning. They're 1.35 across, and we're going to have some math here. So 3.9 divided by 2 is 1.95? Yeah, 1.95. And then as far as the height goes, 0.27 divided by 2, 0.635. So negative 1.95 and 0.635. Okay. 1, 2, 3, 4, 5, 6, 7. All right, so negative 1.95. And then 1.905. Hey, that's right, actually. Okay. Negative 1.95. And negative 0.635. Negative 1.95. And then negative 1.905. Which I may have already been at. 5 and 1.95. .635 is correct. Negative 635. All right, there we go. And then we just go around the circle. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we need to place a 3D body based on the size. Or no, wait, we actually need a big pad. For the heat sink. Oh, this is going to make me do something ridiculous too. All right. And this pad is going to be 3.2 by 4.9. So enormous. And it's 0, 0. All right, well, that can't be right. Oh, I didn't place them out far enough. Dang it. Should have been 3.9 plus half of whatever 1.35 was. Whoops. 0.675 plus 1.95. 2.625. Negative 2.625. Okay. Five. Okay. All right, so that's our full pad. We'll name this, I don't know, ground or something. We'll probably have to add a pin here actually on the symbol for it. Designator, ground, name, ground, turn the name off. All right. Now I need a 3D body. Where is the size? I can find it in the other data sheet. Okay. 3.9 by 4.9, it looks like. Change this grid to millimeters. Probably need like 0.1. Alright. So we need to start at the way this is drawn. Whatever half of 3.9 is. That 2 will be fine in this case. 2 over 2.5 up. It's 2 over 2.5 up, so it's right there. And then we just do this grid. Okay. All right, we need to extrude it. What is the height of this thing? Looks like 1 millimeter max off the board, so that's what we'll do. Millimeter, and we're gonna change the color. That's probably fine actually. Okay. Go 3D view. There it is. Nice little fake part. Okay. So then we will save this to the server. Hopefully have no issues, and then I will probably call it here. Okay. Actually, just place it real quick. There it is. And we'll just drop that in there. All right. Exit out of this, save it. This is going to be another U part. I'll have to add to the bill of materials real quick. What are we on? U8, it looks like. Okay. I need to find, here we go, this part on DigiKey. Hey, and it's in stock. Good to know. All right, part number. then that's U8, so here we can name it U8. Oh, wait. Don't need that. All right, and then we'll validate that. Update PCB document. And it's right here. Drop that over here. That's going to be probably the hardest thing to solder out of everything here. Well, maybe not. It'll take a careful touch. All right. Our list of components grows ever bigger, but we're making good progress, and hopefully we'll find a way to fit all of this stuff onto a board. Although I can't imagine how at this point. So, all right. Well, thank you all for joining me tonight. We're getting close to being done with the schematic, at least done with the initial stuff. We're still going to have to go through and add test points and jumpers anywhere that we think is necessary, but we're getting there. Still a ton to do on this project, but a lot done so far. All right. I will see you all later.